Have you ever wondered if there's a science to making the perfect move? Whether you're trying to win a board game or even negotiating a salary? Well, it turns out there is. And today, we're diving headfirst into the incredibly powerful world of game theory.
Yeah, I know, it sounds like the setup for a really weird joke, right? But the answer tells us something pretty profound about how the world actually works. Every single one of these is a situation where the outcome doesn't just depend on one person's choice, but on the choices of everyone involved in the game.
And there it is. That's the core idea. Game theory is basically the formal study of strategic interaction. It's this powerful lens that helps us understand a world where my success often depends on what you decide to do, and of course, your success depends on what I decide to do.
So, how did this pretty simple idea grow into such a powerful science? Well, let's take a look at just how far its branches have spread. It's kind of mind-blowing.
What's so fascinating here is the sheer range. I mean, sure, economics and politics, that makes sense. But biology? Think about it. Two animals fighting over the same piece of food are in a high-stakes strategic game. Even a jury room is a kind of game, where every juror's vote can influence everyone else's. Game theory gives us a universal language for strategy, no matter what the playing field is.
And this isn't some new idea. This toolkit has been developing for nearly a century now. It started with these mathematical foundations back in the 20s, then this landmark book in 1944 really put it on the map. In the 70s, it made the huge leap over to biology, and by 1994, its importance was totally cemented with a Nobel Prize. So yeah, this field has a serious legacy.
Okay, to understand how game theory really works, we first have to get to know its engine, this core assumption of the rational decision maker. This is the bedrock that the entire system is built on.
Now, I know what you're thinking. This sounds incredibly simple, almost obvious, right? People look at their options, figure out what they want, and pick the one they like the best. But the real power is in that simplicity. It gives us a predictable, logical starting point for analyzing behavior.
And this right here is the crucial point. Game theory doesn't judge your preferences. You could prefer pineapple on pizza? Hey, that's fine. Rationality in this world just means that if you say you prefer pineapple on pizza, you actually choose it when it's on the menu. It's all about consistency.
So, this whole theory really just needs two things to get going. First, what are all the possible moves a person can make? That's your set of actions. And second, how does that person rank those moves, from their absolute favorite to their least favorite? Those are their preferences. That's it. That's all the info we need to start building a model.
Now here's a subtle but super important detail. The theory only cares about the order of your preferences, not how strong they are. It just needs to know that you prefer, say, coffee over tea. It doesn't need to know if you only slightly prefer coffee or if you absolutely despise tea. All that matters is that simple ranking, coffee first, tea second. It's what we call ordinal, not cardinal.
Let's test this out. Imagine a simple choice, an apple or a banana. You pick the apple. Okay, so that tells you prefer apples to bananas. Simple enough. Now, what if we add a third choice, a carrot? The menu is now apple, banana, and carrot. If you suddenly choose the banana, well, according to the theory, that's not rational. Adding a carrot to the list shouldn't magically change your original preference for an apple over a banana.
This brings us to a really important idea in any science, really. The models we use are just that, they're models. They are tools we use to understand the world, not perfect one-to-one copies of it.
And this quote just nails it. A model is useful precisely because it leaves things out. It strips away all the noise to focus on what's essential in a situation. The goal isn't perfect realism. It's about getting useful insights.
Let's use an analogy. If you're driving from Florence to Venice, a standard flat road map is the perfect model, right? Assuming the Earth is flat for this particular trip is not only fine, it's actually incredibly useful. It gets you where you need to go, plain and simple.
But what if your trip is from Beijing to Havana? Well, all of a sudden that flat map is completely useless. Now you need a totally different model, a globe, one that assumes the Earth is a sphere. The Earth itself didn't change, but the purpose of your model did.
So the crucial point is this. You should never ask if a model is right. The only question you should ask is it useful for the question I'm trying to answer? The flat Earth model is technically wrong, but for a short road trip, it's absolutely the right tool for the job.
And that brings us to our final section. Because if models are just simplifications, then we have to be honest and acknowledge that the theory of rational choice, as powerful as it is,
definitely has its limits.
Now, make no mistake, this theory is a giant. It's the absolute foundation of modern microeconomics. But we also know that real, live human beings don't always behave with perfect logical consistency. In fact, experiments have shown that adding a clearly worse third option can sometimes manipulate people into changing their preference between the original two choices, which directly contradicts what the model predicts.
So we end with this really important question. Game theory gives us this powerful logical map for navigating strategic decisions. But its power comes from simplification. It often leaves out messy things like human emotion, psychological biases, and all that complicated stuff. The ultimate skill, then, for any strategist is knowing when to trust the map and when to pay attention to the parts of the world it conveniently leaves out.